Hi, and a very warm welcome to this, the final in our series of the Certificate of Renewable Energies. There's one energy source, well, renewable energy source that we're yet to explore, and we've come to the middle of the North Island to show you. So let's take a look at geothermal energy. Chris, before we get into the actual process of harnessing geothermal energy, what's the history of this plant? How long have we been harnessing that energy?
The first electricity was generated here November the 15th, 1958. So the 50 years comes up this year. There's a big celebration planned here. That was the first one in the world that used liquid resource. Before that, there was a plant built in Italy, Rotorua. That was dated from about 1910, 1913. That tapped dry steam. There's also a plant in California, Geysers, which started up about the same time. It actually was a month later than us, and that also harnessed dry steam. But we were the first in the world to harness hot water, and from that, most of the geothermal fields in the world have developed from our technology.
So explain that innovation. How does it actually take place, and what are the advantages?
Okay, the Rotorua and Geysers, when they drill down into the ground, the fluid that enters the well is actually dry steam, and it can come out and go straight to a steam turbine. Here, it is hot water at about 500 metres to 1.5 kilometres depth. The water is about 230, 240 degrees, hotter than in your oven. Now, the pressure is so great that it is there as water. When we bring that fluid to the surface, it flashes. So on the surface, it's a mixture of steam and water. With the temperature that we have and the pressures at the surface, it's about 1 part steam to 4 parts water. So we have to separate the steam from the water. We can use the steam, we can't use the water in a steam turbine.
Quite innovative of those early New Zealand thermal energy pioneers there.
Yes, there was nowhere in the world that had this technology. When they actually started doing the experiments, they had to do the experiments with mixtures of air and water, because there was nowhere they could get a large supply of steam and water. And there's a lot here.
So up here is where it all starts. What is the process? How deep into the ground are you going to source that energy?
Okay, behind us here you can see most of the Western Bore Field. This is where about half of the mass flow of our wells still come from. What we have is a well. They use something like a modified oil drilling rig to drill the well. These holes nowadays cost us about $7 million each with these big wells. They put a drilling rig on the surface, they drill down maybe 500 metres for the shallow wells, 2.5 kilometres for the deepest one. And they put steel pipe down to line the well and a big valve on the top. And then they move the rig off the site and we can actually use it. To drill these wells, the big wells, they might use 400 tonne of steel and 200 tonne of cement just to make a well. And all you see at the surface is just one big valve.
So how do you know you've got it right?
Well, we don't. We generally get about 50% of our wells right, but even with spending all that money, we still drill duds. We're less duds than the oil industry, where they only get about 1 in 10 are good. We get about 1 in 2.
That's quite a cost though.
Yes, power stations are a very expensive business. You can't easily predict. We can do things that make our chances of a success greater, but as you go through the exploitation of a field and it gets older, you have to push the boundaries a lot more. Drill deeper wells, drill further out, and your chances of failure increase.
So what are we seeing here going on in the background?
Okay, on the top of each of the wells, we have a wellhead separator. As I said earlier, the fluid comes out of the ground. It's a mixture of steam and water. It goes into a cyclone separator. The cyclone separator, steam actually spirals upwards to them and into a pipe that goes down through the centre and then goes out to the main. The water, being a lot heavier than steam, is flung onto the walls. When it's flung onto the walls, it then runs down the walls into the bottom, goes into a water drum, and then the flow out of the water drum is controlled by an orifice, and then that can either go to discharge to silencer like some of them do, or go to a second separation where we lower the pressure, and then finally that stuff goes into a re-injection system so we can put the hot water back in the ground.
So you're returning that water, it's a renewable resource, you're returning it to the earth.
It is renewable in the sense it's going back in the earth, but it's going back at a lot colder temperature. So we can't have that fluid come back into our wells very quickly, because otherwise they'll die from the cold temperatures. The water goes back into the ground at about 87 degrees Celsius. Still hot to touch, but we can't generate electricity of it. Remember, the water that's in there that's coming up at present is 230 degrees average.
Okay, we've come all the way from Southland to come and have a look at this geothermal plant. Why can't we just dig a bore in Southland?
Because there's nowhere in Southland, or nowhere actually anywhere in the South Island, where you can get geothermal energy. There's only a very small area that's associated with the Taupo volcanic zone. We know where geothermal fields are. We can measure the resistance of the earth, and that tells us where we get hot water. The southernmost one is on the flanks of Mount Tongariro, Kiritahi, and almost all the geothermal fields are between Kiritahi and White Island. There's one up in Northland called Nafa, but there's about 20 in this volcanic plateau area.
So there's no huge power potential in Hamner Springs then, just for lying around and
Yes,
enjoying?
you won't generate any electricity at Hamner Springs, at least not with the depths of wells that we drill here.
Look, there's an impressive amount of pipe work there. How much is there?
We've got about 55 kilometres of big pipes, plus a lot of little pipes. All those pipes are mild steel. The smallest ones are about 300 millimetres diameter, the largest ones 2 metres.
So quite high for maintenance then?
No, surprisingly, because they're so hot, they're only made of mild steel. Because they're hot, they don't rust. They've got about 75 millimetres of insulation on them. Most of it's fiberglass, but the top bits are calcium silicate. And then on the outside of it, we've got 1 millimetre skin of aluminium cladding. That's why it looks so shiny.
Well, Chris, thanks for showing us the first stage. Let's move on and have a wee look at what happens further down. Well, that's how the big boys do it at Contact Energy, generating electricity from geothermal energy. Well, here we are in Rotorua at a small Maori village that owes its very existence to that very same geothermal energy from deep within the earth. Let's find out more. Justin, it's pretty obvious we're in some sort of geothermal area with activity going on, but this is in fact your village. Tell us a bit about it and the history.
Well, it's one of the few living villages in Rotorua where we're right on top of the geothermal. So for hundreds of years our people have used the hot springs for cooking, for bathing. We cool down the water. My great-grandmother's time they would wash their clothes. We boil flax after we've woven it, and it's just a great resource.
And so how long has your family had a presence here?
Probably about the last 300 to 400 years. People didn't always live permanently in one place because they moved around, they followed food, they'd have to go where they grow food. But with the advent of tourism, that changed their lifestyles, and especially here, so people started to live here more permanently.
What was that form of early tourism? Was it Europeans coming in?
Yeah. Early Europeans that came into the area, they were excited about the wonders of the geothermal. Probably more famous was what they called the pink and white terraces. And unfortunately though, they were destroyed in 1886. But the difference with here was we have so many different types of different water that you could bathe in one pool which had high acidities, and that would be for cuts and wounds. Then you could bathe in another pool that had a mixture of mud and geothermal water, and that would be bathed on breaks and bruises. People came here, and this was like a spa resort. People would actually come and live with locals, and they would bathe, they would live in their homes with them, and they would stay for lengths on time to treat arthritis, lumbago, rheumatism. People used to drink the water as well to clean out the system, so yeah.
So the water and mud was a genuine therapeutic medicine and wasn't just psychosomatic?
Yeah, no, definitely. Even still today, people can go to the Queen Elizabeth Hospital in the lake end of town, and you can still have treatments in geothermal water and geothermal mud for the treatment of arthritis, lumbago and rheumatism. Now, it's not going to cure arthritis, and it's not going to, but what it'll do, it'll heat and soften the joint, and it creates pain relief. And so that's carrying on. And if you go back a few years, everybody would take medication. Now everyone's going back to things natural, and that's why the bathing at the hospital, how we've always bathed in the geothermal here is just so popular.
Now, another big use that you mentioned was for cooking. How do you cook? What are the methods of cooking?
Well, we have two methods. The main method is actually using the boiling hot steam, and that's where we can cook meats. Today we can put pots in just like how you would put a pot on top of a stovetop. We can cook for 200-300 people at one time just in a steam vent. Then the other use is water, and that's where we cook green vegetables, shellfish, no meats because the meats tend to have fats, and the fats will make the pools dirty. So yeah, it's mainly just vegetables and shellfish in the pool.
And that's actually going on now with residents of the village. It's not just a tourism thing, it's actually happening. They are using it to cook.
Yeah, it's the locals that of course you'll see them cooking, but you will get the tourist involvement as well, because we serve lunches to our visitors from all over the world. But mainly in the late afternoon, you'll see pots that are inside there. They're for the local residents who live in the village, and there's about 60 of those residents. But there's maybe about 2,000 locals who live in close vicinity who will also take advantage of using the geothermal as well.
Now, we were overlooking at those baths. They seem very hot. How do you actually cool them down to bathe in?
We basically will empty them in the morning and clean them, and then we fill them during the day. So it's quite a slow process. And then about 3 o'clock in the afternoon, we'll block off all the water. The water will then start to cool down, and at 5 o'clock when the village closes down, then the locals will come and have their baths. And if the baths are too hot, well, we cheat. We just hook up a hose, and we use the old-fashioned, well, I suppose it's the new way, and we just cool down cold water and cool the baths.
Now, this pool behind us, we've been standing here for a while, it's actually changing its activity. Is that common? And what's this pool actually doing?
This pool here, it's called koro tiotio, and it means prickly heat. And what'll happen is underneath the ground, the pressures change all the time. So when something big like the geyser is active, the pool can sort of, drop down in pressure, and when the geyser stops, there's a lot more heat happening underneath the ground again, so this pool will bubble away just like what it's been doing while we've been here. We use it for cooking. My uncles used to actually use the water from this here to actually clean their pigs. So they would hang the pig up in the tree, they would get buckets of this hot water, tip it over the pig, and then clean all the hair off. Today you don't see that as much because we all go to Mad Butcher and we buy our meat in town, but I remember growing up and quite often you would see the men come back from hunting and the hot water from this pool would be used.
Now, as far as tourism goes, because it really is another second boom, it's not so much health-based, but they're coming to have a look at the lifestyle and that sort of thing. Do you think they really do appreciate this village setting?
Yeah, one thing about people who come to the village is many of them have travelled the world and they've seen places and they want to see real New Zealand. So when they come to our village, they're actually seeing, a real living Maori village. We still cook in the hot water and in the steam. We still bathe. We've got people from places like China that have museums that have 5,000-year-old artefacts, and you can't take them to museums and expect them to enjoy it because they've got museums in their own backyard, probably better than the museums we have. And it'll be us, we probably appreciate our museums more than overseas visitors would. But when they come to a village like this, the Chinese, they love the fact that this is real living New Zealand.
Now, this is truly renewable energy, but is it forever? Do you notice changes dropping off in some areas, improving in others? Is there deterioration with all the bores around Rotorua and that sort of thing?
Yeah, probably in my great-grandmother's time, there used to be 30 active geysers in the geothermal field. Today there are 5 of those geysers left that are still active, and what I mean by active, still erupting. Many of the dormant geysers, you can hear them bubbling, but no water's actually been exploded out of the ground. In Rotorua City now, we do have a local bylaw where you must be 1.5 kilometres away to actually sink a bore in the ground to tap out the geothermal resource. Some of the new rules that go along with tapping the geothermal is that the overflows that just used to flow down into the drains now has to actually be pumped back down into the ground. So it's renewing that energy, and I think it's a good thing, because what we have noticed since the 80s, when the geothermal dropped off, the geothermal is starting to grow back again. It's becoming, a lot more active. Some of the dormant geysers and some of the dormant pools, water's starting to rise there as well. So yeah.
Now, you mentioned the treatment of flax. We're about to film you treating some flax. What does the water actually do to the flax?
What it does, there's a chemical inside the flax called chlorophyll, and what that will do, it takes the green away, and so we actually boil the flax. And when that flax dries, it'll actually harden a bit like bamboo, and that's where you get the dancing skirt and you get the clicking sound of the skirt. So the name of the skirts is pew-pew, and pew-pew means to swing and sway, and it's that clicking of the skirt. The boiling of the water does that for us.
Well, Justin, being from South, and this is about as close as we're going to get to geothermal activity, it's in your everyday life. Thanks very much for sharing it with us.
Oh no, it's been a pleasure having you here, and look forward to seeing you again.
Well, let's head back to Contact Energy's enormous geothermal plant just outside Taupo and find out how they actually convert that steam and water into electricity. Chris, before we get on to what's happening actually here, what is it that actually forms that steam and superheated water inside the earth?
Okay, well, as I said earlier, it's about the volcanic activity. Because the whole of the Bay of Plenty is being ripped apart by the land underneath outside Gisborne being pulled down under, and it's pulling the thing apart. Now the lava and molten rock is very close to the surface. Now what is happening is the rainwater is falling on the surface and it's trickling down into the earth through the cracks in the earth, and it goes very deep, 3, 4, 5 kilometres. Now there it gets heated by not directly by the lava, but by the rock that's heated by the lava underneath it. And that water gets very hot, it dissolves the minerals in the rock, and then it comes back up through the natural vent pipes, which are these geothermal areas. So when it comes back to the surface, it's anything up to 300 degrees and it's very mineralized.
So what are we seeing here then? This is the extraction point, if you like.
Yes, this is one of the wells. This is well 70. It was drilled about 1955, 56 from memory. It's 520 metres deep and the casing goes down about 400 metres and it's feeding from about 500 metres depth. When it gets to the surface here, the pressure is about 5 bar. So it's about 1 part steam to 5 parts water. That steam is travelling quite fast and the water is travelling a lot slower and travelling on the walls. So it then goes through that bend in the pipe and into the cyclone separator. Same as those Dyson vacuum cleaners, same principle. You're relying on the density difference to get a cyclone to work.
And from here, where to for the steam?
Okay, the steam goes up to the top and then down through that pipe in the centre and then out into that steam line, through a flow meter, into the steam line, into our steam mains. The water spins round the outside of the wall, comes into this water drum. It could go in this grey pipe to the silencer, but to make the plant more efficient, we actually take it to a flash plant through that lagged pipe on the bottom there on the other side. And about 110 tonne of water goes that way and about 25 tonne of steam goes out through that upper pipe. These are flash plants. Originally when they had wellhead separators, they'd only literally get 1 bite of the steam or a lot of steam went up into the atmosphere. Now to improve the efficiency of the plant, they started doing multi-stage flash. Wairaki Power Station has machines that could take steam at 3 different pressures. Initially we only provided the steam at 1 pressure and it cascaded through the process. They did some trials with multi-stage flashing and it culminated in these flash plants that were put in about 30 years ago, 35 years ago now. What they did was the hot water that from each of those wellhead separators, they collected it. They then brought it to these places, lowered the pressure, and when you lower the pressure, the temperature drops, so some of that hot water will turn into steam, a flashing process. And these cyclone separators here then separated the steam out at a lower pressure, and that steam went to station. Now this steam is at a lower pressure, so we can't generate as much electricity from it. The steam from those wellhead separators, about 7 tonne, will give us a megawatt of electricity. Steam from these places, 10, 11 tonne, will give us a megawatt. So it's getting an extra, improving the efficiency of the process.
So this is sort of the end of the beginning of the first stage, if you like, or the end of the beginning of the whole 3 stages.
Yeah,
what happens next?
Well, what we do here, the steam, some of the steam, and it separates at about 2 bar, so the water's 130 degrees. That steam goes to station. The water we then collect out of the water drum behind me, and that goes into the re-injection pipe work. And that re-injection pipe work then takes the water down to station. We run it through the binary plant to get more electricity, and then we pump it back into the ground.
Okay, behind us it looks very much like something out of a science fiction film. What does this actually do, this piece of equipment?
Okay, this is the binary plant. It's quite new. We only put it in 2005. It improves the overall efficiency of our power station. We take the heat from the hot water, we use it to boil pentane, which is like a petrol, but it boils at 28 degrees C. And that boiled pentane, we then have the vapours go through through a turbine, like a steam turbine, and they generate more out. Those turbines drive a generator, and then the pentane goes up into the condensers where all the fans are, and then it condenses back down, so the pentane is recycled, and it drops the temperature of the separated water from 130 degrees down to 90, 87 degrees. So we get an extra 14 megawatts to supply to the grid by doing this process.
Now, as far as geothermal energy goes, do you see it always making these steps and advances and becoming more and more efficient?
Yes, geothermal has, throughout its thing, tried to improve its efficiency. And there's a lot of these AUMAT plants going in because the separated water, you can get additional power without having to get more fluid out of the ground.
Very much tomorrow's energy source then.
Well, not so much tomorrow, but it's lowering the overall cost because you don't have to build a new field. Rather than have to build a new power station and all the infrastructure, you've only got to build a small part of it because you've already got the hot water on site.
Well, should we go and have a look at the actual power station?
Okay.
As we can probably tell watching, or people can tell, we're in the heart of the power station. Where exactly are we?
We're here. This is the IP floor. We've got 2 machines running. There's 2 old machines mothballed. Now the steam comes in here at 3.5 bar, exit at atmospheric pressure. It goes into that big manifold behind me. Now these machines have been running 50 years. Originally when they were here, they had analogue instrumentation.
Yes, we saw that there.
Yeah. Now they've gone all digital and we don't need operator in attendance because we get so much more information goes back with the new instrumentation. As well as these IP machines, we've got 4 LP machines and 3 mixed pressure machines. The MP machines are 30 megawatts each, the LP machines and the IP machines are 11 megawatts each.
What we're seeing, to me, a layman, is something very similar to a hydro plant.
Well, it's a big hall which generates electricity. Our machines are horizontal, hydros are vertical. These are massive structures, these are small and light. To engineers, they're chalk and cheese. To members of the public, they probably just think they're the same.
Chris, thanks for letting us have a wee look at your world here.
Oh, I'm really pleased to see you around.
Well, thanks for tuning into this, our final in the Certificate of Renewable Energies. If this course interests you, or any other offered by SIT for that matter, then don't hesitate to call 0800 SIT to learn for more information. We'll look forward to catching up with you next time. Hello and a very warm welcome to this, the final in our series for the Certificate of Renewable Energies. Sorry, I got lost. I thought you were talking then. I was watching your lips. You were singing, weren't you?